Everybody. So this video is if you are stuck on any of these homework problems, then you can go watch this video and get some help on it. So let's just go ahead and get started. We're talking about number one. We're trying to determine whether each relation is a function. We want to justify our reasoning in each case. A function is basically the idea of a function is that every x has only exactly one y coordinate, right? X, like a single x value, cannot have different y coordinates. For example, if I have the x values 2, 3, 4, 2 can only go to one y value, let's say like 7 or something, and 3 can only go to one y value, let's make it 8, and 4 can only go to one y value, let's make it like 15, right? So what I just drew would be a function. But if 4 also went to like 13, then that's not a function, because imagine like the 4 represents time, right? After 4 hours you are 13 units away from home and you are 15 units away from home, right? At the same time you're 2 different times away from home, right? So what we're looking for is in this, so is we're looking for repeats in the x coordinate, right? So we're just looking at the x coordinates and saying, does it repeat? And here it does, right? We have the 8's repeat and they both have different y coordinates. So this would be not a function, because x has, and it says justify your reasoning as well, right? So it's not a function because x equal 8 has 2 y coordinates. All right, so the next one we're looking for the same thing, right? We're looking at all the x coordinates and we're trying to see, does it repeat at all? And negative numbers are not the same thing as positive numbers, so this one does not repeat, and so therefore it is a function. So we're going to say yes, it's a function, and the reason is, every x value has exactly one y value. Right, when we're looking at graphs, we're doing the same basic thing. Like, you can't have a single x coordinate where there's 2 points on it, right? So you're just looking at like this one, there's only one point above -2 as an x coordinate. There's only 1 point above -1. There's only 1 point above 0. There's only 1 point above 1. There's only 1 point above 2. So yes, this is a function. And because there's not 2 points with the same x coordinate. Okay, look at D. Look at 1, you have an x value of 1 gives you 2 y coordinates. It gives you y equals 1 and y equals -1, right? Like, let me just show you this. That I could put both these functions, both these points would be on my graph, right? So you see the x repeats 1 and -1. So this is not a function, right? Because there's 2 y coordinates for one x coordinate. And the last one, same idea. All the points are good until you get to here, right? We could write -1, 0 and -1, 1. Those are both points on there and they have the same x coordinate. So basically that's the same idea where you're in 2 places at the same time, which is not possible. So this one is also not a function. And the reason I'm giving is because these 2 points, right? Those are the 2 points that make it not a function. All right, number 2, we're finding the slope of each line, and we're make sure we justify why that's a response. So the first one here, that's our slope. The slope is -2/3, so we're going to write m equals -2/3. How do we know? Well, it's the equation was y equals m. It was in this form, right? So we can see m easily. We can see the slope easily when it's in that form, right? The next one is not in y equals mx plus b, but it's in that other form, the point slope form, which is this, right? It's in point slope form, which you can see the slope right here, which is that 5. So we're going to say m equals 5. How do we know? Because it was in point slope form. Okay, and then the next one, this is right now it's in standard form, but so we can't really see the slope, so we need to get it to be in slope intercept form, and we're going to do that just by solving for y. So we're going to move this x over, and we're going to get 3y equals negative 7x plus 11. And then we're going to divide by 3. And we're going to get y equals negative 7x over 3 plus 11 thirds. And so our slope is negative 7 thirds, right? So our slope is negative 7 thirds, because that's the m, and the y equals mx plus b. All right, next is part D. We're given 2 points. To find the slope between 2 points, you're going to use the slope formula, y2 minus y1 over x2 minus x1. So basically here we're going to get 7 minus 4 over negative 1 minus negative 2. This is going to turn into 3 over negative 1 minus a negative is a positive. So negative 3 over positive 1. So the slope here is 3. All right, same idea for this next one. We're going to do that same formula. This time we're going to do 5 minus 5 over negative 4 minus 3, which is going to give us 0 over negative 7. 0 divided by anything is 0, so our slope here is 0. Last one here, we just need to find the, you can write down 2 points if you want. You can actually write down negative 7, 1, and 0, 0. And then you could do that same formula that we just did, but you can also just do rise over run, right? We're going down 1 over 7, right? 7, so the slope is going to be rise over run. Negative 1 over 7 would be our slope in that case. All right, let's keep going. We want to write the equation of a line with a slope of 4. It passes through that point right there. Anytime you get a point and a slope, you want to use point slope formula, which is this one. And we just plug in our y coordinate right here, which is 1. We plug in our slope for m, which the slope here is 4. And we plug in the x coordinate here, which the x coordinate of this one is negative 3. All right, and we should simplify this a little bit. Y minus 1 equals 4. X double negative makes a positive, right? So x minus negative 3 turns into x plus 3. The instructions don't say anything about writing it in points slope-intercept form, so we don't have to actually do anything with this. We can just leave it like it is. All right, next we want to write the equation of the line that passes through those 2 points. We're not given a slope here, so we actually need to find the slope first, right? So we're gonna do our little slope calculation, which is 5 minus 5 over 6 minus 2. And we're going to get 0 over 4, so our slope is 0. So we're doing y minus a y coordinate, which let's use 5 as our y coordinate, right? We're using this point, equals the slope times x minus the x coordinate, right? We used that there, and we used this 5 over here, and we used our slope right there, right? That's where those are coming from. And we should just simplify. So we're getting y minus 5 equals 0 times x is 0, 0 times negative 2 is 0, so we're getting 0 here. In this case, we should just move this 5 over, right? Add 5 to both sides, and we're going to get y equals 5. All right, and that's the equation of a line. It's a horizontal line. The slope is 0, so just straight across the line like that. All right, let's keep going. Number 5 says find the x and y intercepts of this graph. So in this case, we have to remember if I'm finding an x-intercept, that means the y coordinate is 0, right? Anytime you're on the x-axis, the y coordinate of those points is 0. So we are plugging in 0 where we see y, right? So we have 9x minus 6 times 0, right? We're replacing y with 0. This is going to give us 9x equals negative 18. And we're going to solve for x. We're going to divide both sides by 9. And we're going to get x equals negative 2. Right? So we have a point. X is negative 2. Y is 0. And that's this point right over here on the graph. Right? So just put that point on there. We also need to find the y-intercept, which the y-intercept occurs when x equals 0. So we're going to replace the x with 0. right? We're putting a 0 where x used to be, and now we're left with negative 6y equals negative 18. We solve for y, divide both sides by negative 6, and we get y equals positive 3. Good morning. Oh, sorry about that. A student just walked in. So we have a coordinate point of the x coordinate was 0, and the y coordinate is 3. So we have this point 0, 3, which is right there. And once we have those 2 points, we can just graph the line by connecting the points with a straight line, and that's the graph. All right. Number 6 is asking us to use the given information to determine if the lines are parallel, perpendicular, or neither. And so we need to remember if they are parallel lines have the same slope. Okay, so we need to remember that. If they're perpendicular, they have opposite reciprocal slopes, which means they're different signs and they're flipped versions of each other, right? So when we look at this first one, we're looking at 2/3, negative 3/2. So first of all, notice that they are different signs. The slopes are different signs, which means they're opposite. And then 2/3 is a flipped version of 3/2. So these ones are perpendicular. And the reason they're perpendicular is because the slopes are opposite reciprocals. Okay, for part B, we can't actually see the slope in these right now, so we need to again solve. So we're going to start by moving this 4x to the other side, and that's going to give us 6y equals negative 4x plus 24. We divide both sides by 6, and we're going to get negative 4x over 6 plus 24 divided by 6 is 4. If we simplify this a little bit, it's going to be negative 2/3 x plus 4, right? Negative 4, 6 simplifies to negative 2/3. And then for line B, we're going to do the same thing. We're going to subtract the 2x, so we're going to get 3y equals negative 2x plus 10. We're going to divide both sides by 3, so it's going to be negative 2x over 3 plus 10 over 3. And all we care about is the slopes to determine if they're parallel, perpendicular, or neither. So we're looking at those, and we see that the slopes are the same. So these lines would be parallel, right? Because the slopes are identical. Right? The slopes are exactly the same. All right, for part C, you're given 2 points for each line, and again, all we care about is the slope. So we're just going to find the slope for each line, right? So that's just that slope formula. Subtract the y coordinates, you divide by subtracting the x coordinates. In this case, I get negative 2 over 0, which anytime you divide by 0, this is undefined. And you need to remember what an undefined slope looks like, right? Undefined slope looks like vertical, right? It's a vertical line. And then for line B, we need to do the same thing. We're going to subtract the y coordinates, and then we're going to subtract the x coordinates. And this time we're going to get 0 over 2, which is 0. And you need to remember what a slope of 0 looks like, which a slope of 0 is straight across like this. And so these lines they turn out to be perpendicular because one is vertical and one is horizontal, and vertical and horizontal lines are perpendicular. So these ones would be perpendicular. All right, let's keep going. Just a few more. We want to write the equation of the line through the point 1, 2 and parallel to that given line. So again, what we need is a point and a slope. We need to get the slope off of this line and make sure that our new line has the same slope. So we're going to put this in slope-intercept form so we can see what the new slope is. We're going to get negative 6y equals negative 3x minus 12. We're going to divide both sides by negative 6. And we're going to get y equals negative 3x over negative 6 plus negative 6 divided by negative 12 is 2. And we can go ahead and simplify this as well. And negative divided by negative is positive 1/2. So this is the slope I want to use. right, my slope has to be the same because they're going to be parallel and it has to go through that point. So we're using point slope form. Right, you have a point and a slope. These are going to be, that's our x coordinate of our point, that's the y coordinate of our point. So we're going to do y minus 2 equals that slope that we had, 1/2 x minus 1, right, where these came from up there. And you can just leave it like that, because again, it's not specifying that you need to write it in slope-intercept form or anything, right? You just have to write the equation on the line. That's the equation on the line, so you just leave it just like that. Number 8, we want to write the equation on the line through that point that's parallel to that line. And so again, we need to put it in slope-intercept form so that we can see the slope. In this case, it was a little different just because the x wasn't over here, but the 4 was over here. So we move it by subtracting it in this case, and divide both sides by 2, and we get this. And so the slope is 4. And so our new line will be y minus 4, right? We're getting that 4 from here, equals 4. This 4 is the slope. It's coming from this line, right? Because they have to be parallel. And then x minus the x coordinate up here is 2, so we're going to write that 2 down here, right? And that's the equation of our line. Again, it doesn't say anything about slope-intercept form, so we just leave it like that. Okay, number 9, we want to graph y equals 4x plus 2. Just remember that this is the slope and this is the y-intercept. So our y-intercept is going to be at 2 on the y-axis, right? And our slope is 4. Sometimes it helps people write 4 as a fraction, 4 over 1. So we go up 4, 1, 2, 3, 4 over 1. You could do it again, up 1, 2, 3, 4 over 1. And you can just connect those points with a line. If you have a straight edge, use a straight edge, but it looks like that. All right, last one. Given the sequence 12, 15, 18, 21, we want to find the common difference. The common difference is what number do we add each time. In this case, we're adding 3 each time. Sorry about that. Okay, so that adding 3 is our common difference, right? So our common difference here is 3. Now the explicit formula, we want a formula so that, let me write this information in a different way, so maybe it'll help you see it a little bit better. We want a formula so that my first term is 12, my second term is 15, my third term is 18, and my fourth term is 21, right? So we're going to call this A, and this will be AN, right? So when I plug in 1, I get 12. When I plug in 2, I get 15. When I plug in 3, I get 18. And the general idea is it's basically the same thing we've been talking about. It's basically the same as y equals mx plus b, right? It's that same idea. Your slope is going to be that common difference. And sorry, I'm going to write it in the sequence notation. So my slope is going to be this 3, because that's the common difference. I should be using n as well. And then I just got to figure out, well, what's the number I add here? And if you remember, that should be like the y-intercept. And the y-intercept occurs for when x is 0, or when you have 0 in the x position, which in this case is n, but it's the same thing, xn. So I just got to figure out, well, what's the number down here that corresponds with 0, right? So you can see we're counting down 4, 3, 2, 1, 0. Here we're counting down 21, 18, 15, 12. What should come before 12, right? You can think, what number plus 3 gives me 12? And that number is 9. And so this number here should be 9. And you can check it by plugging in numbers, right? So you can say, okay, well, A1 should be 3 times 1 plus 9, which is 12 plus 1. Sorry, 3 plus 9, which is 12. And so that worked for the first term. If I want to find A2, I plug in 2, so it's 3 times 2 plus 9, which is 6 plus 9, which is 15. Check, that worked. That's the same value in my table. If I want the third term, then I'm plugging in 3. That's 3 times 3 plus 9, which is 6 plus 9, 9 plus 9, which is 18, which is also my table, right? So I'm checking to make sure that my formula actually works. And so this here is the formula I want to use. To find the 40th term, we're basically just going to plug in 40, right? Because that's how we'll find the 40th term. So we're doing 3 times 40 plus 9. So that's 120 plus 9 is 129. So the 40th term is 129. And that's it. All right, so good luck on this. I will be here in the morning and at lunch. So if you need help, come by and get more help.